Hey, hello everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and in this video, we're gonna discuss RAG application with Google Gemma and Mongo DB. Yes, guys. So recently, I was creating a video on top of the multimodal RAG, and I created one playlist on top of that. If you haven't checked that, guys, please go and check with my YouTube channel. There you will find out around 6 to 7 video inside that playlist. Inside this multi-modal retrieval augment generation. So each and everything I try to cover with respect to this concept. Now I came up with one more new series where we are going to discuss NoSQL databases as a vector search. Yes, so we can use this NoSQL databases also as a vector search, like we have other databases, Pinecone, Weaviate, the dedicated vector databases. Okay, in a similar way, we can use this NoSQL database also. So here, guys, I decided around 5 video. So in the first video, I will discuss about the MongoDB vector search. In the second one, I will be talking about the Cassandra, then Elasticsearch, then NoSQL, and then Postgre. Okay, so you will get around 5 video inside this series. And here, we are going to be start from the MongoDB itself. Each and everything I will show you here itself in this tutorial. It's going to be quite long. So because each and every code I will be writing in front of you. So before starting with this session, let me tell you why we are going to be use this MongoDB as a vector search and what is the benefit of it. Not a MongoDB, I'll be talking about with respect to the entire NoSQL databases. Okay, all the NoSQL databases and all. Now, guys, here is my YouTube channel. If you want to learn the generative AI, definitely you can check out over here. So you will get the different video with respect to the RAG, generative AI, Llama Index, and all. And I'm uploading like different video, different other video as well. So soon you will find out so many content on my YouTube channel. If you haven't subscribed, you can subscribe, and yes, you can press the notification button so that whenever I'm uploading the video, you will get the notification. Now, first of all, what I'm doing here, so here you can see, guys, I just kept one image from the internet itself. So here you will find out the different database, right? So let me highlight all these databases. So here we have this Chroma, right? Chroma, LensDB, I think we have used in the previous application. Then we have this Malvias, right? A Quadrant is there, it's very popular database. Now here you will find out the Weaviate, Pinecone. So we know these databases, actually it's a dedicated vector database. Now, apart from that, you'll find out some other databases, which is not a dedicated vector database, but yes, definitely we can use those database as a vector database. So in that, you'll find out this Cassandra. I think you have seen this Cassandra and all people are using for the as a vector database. Okay, because here also we can do the similarity search. Postgre is also there. Postgre actually it's a SQL based database, but here, yes, here also we can do the similarity search. Now, other databases like OpenSearch and Click House and all. Okay. Now in this one, I can write few more. So MongoDB is there. I can use the MongoDB. Now I can use this Neo4j. Okay, Neo4j. And here you will find out the other databases like Elasticsearch. Okay, Redis we can use, and Rocket and this single store and all. So different other database. But this MongoDB, Neo4j, Cassandra, Postgre, these are the quite famous one. And here we are going to be use this database for the other perspective also. Okay, not for the embedding. We are we using this particular databases for the different other users as well for storing the entire data. Okay, now guys, here you'll find out. So these all the databases, this one, this Chroma, Vespa, LensDB, Quadrant, these are the open source database they have mentioned over here. It is under the Apache license. Now here you'll find out this is not a open source, this is for the commercial purpose. This one, Pinecone, Weaviate, similar to this Pinecone, Weaviate. So here we have the Elasticsearch, Redis. So this is also a commercial purpose, means this is not an open source. Now here, apart from that, if you will come over here in this particular site, so Postgre, Cassandra, this is the open source database which is under this Apache license. Okay, but just focus over here, dedicated to vector database. Okay, dedicated to the vector, and dedicated it is not dedicated to the vector, we can use for the multi-purpose for the other thing as well. Okay, these databases which I'm pointing out over here. Now whenever we're talking about the vector database, see, let me write something over here. So let's say if we're going to talk about NoSQL database, so this NoSQL database itself we can divide into 4 parts. So the first part is called key value pair. Key value pair. The second is called column family. Okay, column family, Coleman family. Then the third one is called graph database. Okay, the third type of database is called graph database. The fourth one, which is called document based database. Okay, so these are the different database, different type of NoSQL database. Now here, if you're going to talk about this key value pair, so here I can write HBase. Okay, now this one, a column family, Cassandra is there. Here graph database, Neo4j is there. Okay, this document database, MongoDB is there, and we have like several databases, right? You'll find out like hundreds of databases inside these particular category. So these databases, actually, see, we have other side, this other than this one, we have the SQL databases, SQL base. So there you'll find out the MySQL, which is very famous. You'll find out the Oracle. Okay, you'll find out the other databases. So let's say PostgreSQL. Okay, PostgreSQL is there. Then you'll find out the MySQL, Oracle, Postgre, SQLite, and we have a long list. Okay, longer list. Sorry, SQLite, LITE. So we have a longer list related to these particular databases. So this database we use for for storing the structured data, and this database we generally use for adding the for storing the unstructured data. Okay, this NoSQL databases. I think we know about it. Now, other than this one, nowadays one more database which is getting quite popular. There is a vector database. Why? Because nowadays you'll find out in every LLM based application we are using the embeddings, right? Embedding. This embedding is nothing, it's a vector only. So for storing this embeddings and all, because whenever we store the embedding, we require the index, and inside the index, actually the particular index we are going to be stored that vectors, numerical value. So here we have the different database like Pinecone, Weebit and all. But guys, here inside this database, see, inside this databases, inside the vector database, we cannot store the data. Okay, it is not possible. We can only store the embedding over here. But if we want to talk about this NoSQL databases, so here HBase, Cassandra, Neo4j, MongoDB, we can store the data. We can store the data, and along with that, they have given the option for storing the embedding also. Getting my point? Means on top of the embedding, you can perform the similarity search. Okay, similarity search. Now SQL also. So in the MySQL, in the Oracle, in SQLite, you won't find out this thing, but yes, Postgre is giving you that. Postgre is giving you that. Now, apart from that, we have other solution as well, like Redis, okay, Elasticsearch and all. So we'll be talking about these databases also. So I decided around 5 to 6 lecture for this particular series, and definitely I'll be teaching you everything. Got it? So here, what I'm doing. So in the previous like solutions and all, we have used the different vector databases. I have used the LensDB, Pinecone, VB8, Wise. Now basically we are going to be use a different NoSQL databases. So along with the data, we can store the along with the data, we can store the embedding as well. And here, guys, one more thing. See, if you will go in the industry, so the data is going to be quite complicated. Okay, the real-time data, actually, it's going to be quite complicated. You will get so many columns and all, right? So here you will be taking the hybrid approach. Now in that, what you do actually in this hybrid approach or in the combined approach, you take the NoSQL data for storing the data, as well as you take the vector database specifically for storing the vector. Okay, so that solution also I will tell you, the combined solution. So you can implement this particular solution in the real time. Getting my point? So that you can implement this particular solution in the real time. Hybrid solution also I'll be talking about. So NoSQL data plus vector database. So here what I will do, so right after this MongoDB, so as a NoSQL database, I will take this MongoDB, and as a vector database, I will take the Pinecone, this Pinecone. Okay, and what I will do, I'll be taking the data, and this data I'll be storing inside the MongoDB, and corresponding to the data, I'll be storing embedding inside the Pinecone. Because see, this is also storing embedding inside the MongoDB. Also, we can store embedding, but there can be some advantage on inside this Pinecone. Means it might give you the faster search, it might give you the it might give you the faster search, or maybe you can store as much as embedding compared to this MongoDB. Okay, you can do the scale basically compared to this MongoDB, more scalable. It might be the more scalable. So there are lots of benefit. There might be lots of benefits. So people, what they can do, so instead of using the NoSQL database in the real time, particular for the embedding, they can use the NoSQL database just to collect the data, and corresponding to the embedding. Okay, so with respect to the embedding, they can use any vector database, right? So this type of solution is also exists in the industry, and definitely I'll be talking about. Now here, I hope this thing is clear to all of you. Now coming to the point. So if you will look into this vector database, so see, this is the website where actually you will find out the complete comparison. Okay, the different the entire comparison with respect to the all the database. So you can see over here, this is the Apache Cassandra. Now based on what? Based on this license, deb language, okay, BCC launch, filters, hybrid search, facts, geo search, multi-vector. Based on that, basically what they are going to do, they are going to make a comparison. Now just scroll down over here and look into this MongoDB, right? So they have given you the complete detail of the MongoDB. So see, dev language, they have created this database in C++ Java, right? Now apart from this one, just check over here this search one, right? So inside this search one, actually you'll find out a different other thing. So yes, filter is available, hybrid search is available, fact facet is there. Okay, now apart from this one, you'll find out this geo search, yes, it is available. So guys, here actually you can check, you can make a comparison. Okay, you can make a comparison with respect to your data, and definitely I will give you this particular link inside the description. So based on the multiple factor, actually you can check over here. So I hope this thing is clear. Now guys, what you can do, so each and every detail actually you can check, not like that. So once you will click over here, you will be able to find out each and every detail with respect to this database, right? Whatever you want. So just try to explore it from your side, and based on these particular like columns, right? You can select the database, right? I hope this thing is clear to all of you. Now here coming to the implementation, then how we can make the implementation of this RAG application with this MongoDB and this Hugging Face Gemma. So what I'm doing, so first of all guys, here actually I'll require few libraries. So let me connect it. Let me connect with my runtime T4 GPU, save it, and then connect it. So first of all, what I'm doing, I'm going to be install few libraries over here. So here is what guys, here is my library. Now let me keep these other library. So I will give you the idea why we are using this library. So here we have PyMongo, pandas, sentence transformer, dataset. Now here you'll find out the transformer and accelerate. Transformer, Hugging Face transformer, accelerate for the GPU. And here for the MongoDB, actually we are using this PyMongo. Sentence transformer for the embedding. Okay, sentence wise we can make the chunks and all, and with respect to that we can do the embedding. So let it install. Until what I can do, I can write my further code. So here guys, I will be required few statements. So here I'm writing from database. Okay, from data sets, not database. I'm going to be import something. So here I'm going to be import this load data set. Now the second one is what? So here I'm going to be import panda. So first I will have to perform the data ingestion, and then what I can do, so after the data ingestion, I can create my retrieval. So let it install, and then basically I'll be creating my data ingestion. So here I think it is doing now, it is loading. So in between, what I can do, I can write my further code where let me import the data set. So here I have my data set. Let me show you the data set, and let me mention it over here, the name of the data set. So guys, this is the name of the data set which I'm going to be load from the Hugging Face itself. So let me give you the name of the data set. Let me paste it over here. So the name of the data set is what? Embedded movies. Okay, so what I can do, I can copy this one and I can search in front of you over the Google itself. So what I will get guys, let's see. So here if you will search guys, you will get a link of this particular data set, embedded movies. So this is the entire data set. Now see here, along with the embedding, what I have, tell me, along with the embedding we have other columns as well, right? So let's try to explore this data set, what we have over here. Now here we have 1.5k rows. So we are going to be store this data inside where? Inside the database, inside the MongoDB, and then I will be performing the similarity search based on this embedding. And not only the embedding, we'll try to fetch the other information as well with respect to that. So first of all, what I can do here, so let me do one thing. Let me run it. Let me load the data set, and this one I can keep inside the variable. That is what? That is my data set. Now after loading the data set, what I will do, so first of all guys, let me show you the data. So here, if I will write this data set, and the data actually it is available inside this train. Now what I will do, so here actually I am going to be convert this data into the data frame. So it's going to be data frame. Now what I will do, so I will be keeping it inside this data frame, and this is going to my data. Okay, let me run it and let me show you my data. Now first of all, what I can do here, okay, I imported the pandas. So here is what guys, here is my data. Now just look into the data. Here we have a multiple column. So it's a movie data. Inside this data, you'll find out the director name, title of the title means movie name, IMDb rating, plot embedding. So here is my embedding, embedding with respect to the column, but I'm going to be deleted. I'm not going to use this predefined embedding. I'll be creating my own embedding. Then awards, nominations and all, rated, countries, type, writers, different one. I can simply check with a column. So if I'm going to write like this, data dot columns, I'll be getting my column name. Okay, so I hope it is clear to all of you. So these all are my column, right? Now plot, movie plot means the description of the movie, full plot, movie plot. So here actually you will find out the description of the movie. So these particular column we are going to be used for the embedding. Okay, now what I'm doing here, so first of all, here let me check with the null value. So if I want to check with the null value, simply I can call this data dot is null, and here I can write this sum, right? Now on top of this data, on top of the tabular data only, I'm going to be create a rag system. So see, we have a multiple null values over here: 13, 28, 308, 913, 928. Okay, many more null values we have. Now if I want to check the total null value, simply I can call the sum on top of it, right? So here you can see here is a sum around 1400 null value. Now what I have to do here, so first of all I have to drop this null value. So for dropping the null value, there is a simple method. Let me give it to you. So what I can do, I can simply call this one, just wait, let me write it down here, data dot drop na. By using this one, we can drop the null value, and here my column name is going to be, so column name basically it's nothing, it's a subject. This parameter they have changed, and here I can pass my null value. So guys, see, if you will look into the entire data, you'll find out the multiple column. But here for the embedding, specifically for the embedding, I just required this full plot. Okay, if you look into the full plot, so you'll find out the complete description of the movie, full plot. Now here you will find out, see, this is the full plot of the movie, means the different movie. Now here you can check with the first one. So this is the complete plot of the first movie. Now inside this full plot, you'll find out we have 48 null values. So yes, definitely we are going to be drop that, because this is the column, main column, which is required to be. So full plot. Okay, and then again, what I'm going to be do, I'm going to be collect the data, means based on this data, based on this particular column, we are going to be drop the null value over here. Okay, so data is there, and yes, it is fine. I'm able to do that. So subject. Okay, it's not a subject actually, it's a subset. I thought it's a subject. Now what I will do here, you can see I'm having a data. So this is what, this is my data, right? So that column was required. That's why I just dropped the null value from that particular column only. Now the next thing is what? So here guys, here plot embedding, I'm going to be drop it because it is not at all required to me. I'm not going to use the same one. Instead of that, I'm going to create my own embedding. So simply I can write over here data dot drop. Okay, and here I can pass my column name, and what I can do, so columns, which column guys? So here my column name is what? Plot embedding. Okay, embedding. So this particular column I'm going to be dropped because it is not at all required to me, and here is the data. So if I'm going to be run it, so definitely I won't be able to find out this plot embedding inside the column name. So see, all the column is there, but I don't have the plot embedding, and I'm able to drop all the null values from the full plot as well. Now let's start with our own embedding, and let's try to store inside the MongoDB. So for that, what we can do, so let me write the code one more time. Here actually everything is perfect, everything is fine. Now first of all guys, we require the model. So this is the model which we are going to be used for embedding. Okay, the sentence embedding, sentence transformer, and through the sentence transformer, I'm going to be use this GTE large. This is the open source model or research based model, which the description and all everything you can check simply with the Google itself. Now let me show you that. So here, once you will go and check with the Google, so you'll be finding out the complete detail of it. So here guys, this is the model name, then Daniel per and GTE large. So generated text embedding model, and it's open source one, and here you will find out the complete detail regarding that. So model download and all, model size, in how many ways it is available, so each and everything you will be getting with respect to that. So this is the particular model which I am going to be used. So first let me load the embedding model, and then basically we are going to be create an embedding of the full plot. Okay, so first of all, here guys, see what I did. I created one method. Let me show you that method. uh, Let me show you that method, and that method actually I'm going to use for creating the plotting of the data. So sorry, embedding of the data. So here guys, this is the method. I created it and I kept in my notepad. Let me give it to you. So here I'm passing my text, then I'm calling this strip method. Then here what I'm doing, after calling this strip, see, if not text dot strip is if not text dot strip, here I'm going to be return this embed, this one means the blank one, and if it is strip one, then I'm going to be what I'm going to do, I'm going to perform this embedding. Now here you will ask to me, Sunny, why strip? Okay, attempt to get embedding for empty text. See, why strip? Okay, so if not strip, so first of all let me tell you what is the meaning of strip. So for that I kept couple of example for all of you. Let's say there is my text. So in my text I have written Sunny is the data scientist who created product of the data. So let me run it, and here you will find out some blank spaces. Now here if we are going to be run it, so text dot strip, so you will find out guys, see, you'll find out the text something like this. Okay, so text dot it is spread. If not, okay, if it is not like this, what I'm saying over here, text dot strip, if we are doing like this, means this one, if it is not like this, so here attempt to get embedding for empty text, means we are saying we don't have a data. Okay, otherwise we are going to be encoded. That's it. Now let's say if I'm going to be write it down, so what I can do, I am simply writing like this, just a wait. So here let me call it. Now what I'm doing, so here this is the one. Okay, so here what I'm doing, I'm going to be take this particular one and run it. Now what I'm doing, see, I'm going to be write this print, yes, it is having blank string. Right now you will be getting in a more specific way, blank space. Okay, white space, blank space. Now here if I'm going to be run it, see, this is my text, and here what I will be getting, I'm not getting anything. Right, means if I am having this blank spaces, in that case it's going to be skip this part. Okay, if not, I know I don't have to do this text dot split, in that case it's going to be skip this part. If we have a normal text, so let's say if we don't have any sort of a this one, so let's say this one, and then if I'm going to be run it, in that case, see, it is showing to me this one. So here you can see text, this is what is my text, and text dot strip. So here it will be showing to me this one. Now I hope this thing is clear to all of you. Let's try to be generate the embedding over here. So first of all, what I have to do, I have to pass the text over here to this particular method. Now for passing the text guys, here I am going to be use this particular column, this full plot column. So data, and here what I have this full plot. Okay, now what I will do, so here let me call this apply. So here is what, here is my apply, and what I will do, I will be passing this get embedding, means I will be giving this particular method get underscore embedding. Okay, get underscore embedding, this is my method name. So this is my method. Let me copy and paste if the spelling is not correct. Okay, great. Then what I will do, I will be keeping the embedding inside the embedding column. So here is what, here I'm going to be write the new column name. So here my column name is embedding. Got it? Now what I will do, so here is what, here is my data, and everything is perfect. So this is what guys, this is my complete code. And if I'm going to be executed, definitely I'll be getting an embedding with respect to my data, right? So it is not defined, means I haven't done it, I haven't executed it. Let me execute this particular part, and let's see. So here I'm going to create an embedding with respect to this entire data. That is what? That's a full plot. Full plot is nothing. It's a description of the movie. Now, after creating the embedding, guys, what I will do? So here I'm going to be store the data inside the Mongo DB. So for that, first of all, I will have to import this Mongo. And here, guys, I'm going to use this MongoDB Atlas. MongoDB Atlas means what? So it's a cloud version of the MongoDB. So if I'm going to be right here, MongoDB Atlas. So let me do it. Let me open it. And here, guys, I have this MongoDB Atlas. I think you will also search. You will get the same page. I have to log in over here first of all. So simply you can click on this try free, and it will give you the option for the logging in. So here I am going to be logging in. Now I can see I already signed up, so no need to do the sign up again. Here I can simply log in to this particular database. If you are doing first time, guys, definitely you can sign up over here. Simply I'm doing a sign in. So yes, it is providing to me a like Google account. So by using the Google account, I can sign up. So here I'm going to sign up with my this mail ID. This the fourth one. You can sign up with any mail ID, whatever you want. So I have already account on this mail ID. That's why I did it. So after sign up, guys, you will, after setting up all the cluster and all everything, right? The free cluster you will get if you are doing first time, you will getting this type of page. Got it? This is the home page. Now here you need to click on this database. So once you will click on this database, guys, so if you have already created a database, if you are using that, so inside this browse collection you will be finding out your database and the collection name, because inside the database we are going to create a collection, and inside the collection actually we are going to store the data. So here what I have my database. This is my database, and inside that you can see the collection. Okay, and here we have a multiple databases, other databases as well. So guys, how to create the database and how to connect with the MongoDB admins. Now let me tell you that part. So once you will click on this database, so here guys you will find out this connect option, right? Connect option. So just click over here on this connect option, and here you will find out the drivers. So just click on this driver, and here actually you will be finding out the different driver: Python, PHP, Node.js, Kotlin, okay, Rust, Ruby, Swift, and here you'll find out the version, different versions. So let's say if we're gonna use Python, I can use the different version of the Python. So here I'm going to use this particular version, stable one. So it will provide you this one, okay, this URL. You can copy it and you can install the PyMongo. Already I did it. I'm not doing it, but yes, if you are doing it, means if you haven't installed the PyMongo inside your environment, then you have to do it. See, let me show you where I did it. So initially itself I written this PyMongo. That's why I no need to run it again, because already I have installed this PyMongo. Now after this one, guys, what you need to do, so here you need to copy this particular code, this one. If it is showing you the single string, just like open it and then copy this particular code and keep it inside your cell. Okay, this one. Now guys, here it is asking about the password. So let me show you from where actually I'll be getting the password. First of all, let me write over here my password. This is my password. Okay, so see guys, whenever you will go through with this Atlas page, now here inside this one you'll find out this quick start. So once you will click on the quick start, guys, it will give you the option for creating the user. So you can write your username, whatever username you want to write, and corresponding to that you can write the password and you can create the user. So that user, see here my username is visible, automatically it will come over here, and you need to write a password. And please remember guys, don't give this angular bracket. Please remove this angular bracket. Okay, otherwise it will give the error. Now apart from this one, so apart from this username and password, so here you can see the database connect option is clear. Now one more thing you need to set up over here, you need to set up the network access. Okay, so here guys, once you will click on this network access, so this will give you the option for adding the IP address. So if you haven't added any IP address, in that case you will have to add it. So here you can add this 0000/0. Just click over here, add the IP address, just write your IP address, okay, this one, and then click on this confirm. You will be able to add it. I already added, and here my status is active, so I'm not going to do it again. I hope this thing is clear to all of you. So you need to configure these 3 services, right? Now what I'm doing, I'm going to check whether it is working or not. If it is working, I'll be getting this particular message. Now here, let me run it. So here is going to be run, and let me check. See, here it is saying ping your deployment, you're successfully connected to MongoDB. So I'm having my client, and with respect to this client, what I can do, I can create my database. So here I'm going to be create my database. I can write any sort of a name over here with respect to the database. So let me write my database name. Here my database name is movie rag. Okay, or movie Mongo rag. So Mongo rag. So this is the name of my database. Now what I can do, I can collect it inside this DB. So this is going to be my database, guys. And now what I will do, so here I'm going to be run it. Now inside the database, I have to create the collection. So here what I'm doing, I'm writing this DB. Now I'm writing my collection name. So Mongo or rag collection. Okay, so this is my collection name, and here I can keep it inside this collection. Now here is my collection and here is my DB. Now what I will do, guys, see, first of all I will show you so whether I'm able to store the data or not. So how I can store the data? So first of all, let me write over here collection and insert one. Okay, insert underscore one. Now let me show you how I can store the data. So I will have to store the data in the form of document because it's a document based database. This one JSON, this is this JSON. Okay, so I'm going to be store the data in the form of dictionary or JSON. So this JSON with respect to the single row, this is called the one document, right? So here what I can do, I can write this name, and here let me write the name. Here I can write Sunny. Then what I'm doing, I'm writing over here age. So here I can write age. Let's say age is what, 25. Okay. Now here I'm writing the, let's say here I'm writing city. So city is what? Let's say city is nothing. It's a Bangalore. 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 Right. So if I'm going to run it Bangalore, so you will find out we are able to insert the data, right? So here if you will check with your MongoDB, just go with the database and here click on this browse collection, and then you'll find out this data, okay, inside the browse. So see, Mongo rag, this is my database. Inside that you can see the collection, and inside the collection we have a data, and with respect to every record you will find out this unique ID, right? So let me delete it and let me store my real data. For that actually I'm working. So what I can do, let me open my code, and here this is just an example which I shown you. You can test it. Now what I'm doing here, so here actually I'm going to be just a bit. So here what I'm going to do, now I'm going to be write a code for storing the entire data, this particular data. If you look into the data, you'll find out the multiple columns over here. So along with all the columns, I want to store the embedding also over there. So this inside this data itself, you'll be able to find out the embedding, which I have created with respect to this full plot column. Okay. Now what I'm doing here, so I'm going to be store it, and for that I have written a code. Let me give it to you. So guys, here is the code. Yeah. So first of all, I'm going to be create a JSON with respect to this particular data. So to underscore big, and here I can pass my data. Okay, I can write the name basically. So here my name is, let's say, records, right? So to underscore tick. Just a second, guys. Let me check. Which name should I write? Okay, great. So data is there, to dict, and this is the name of this particular like the JSON form, right? Then what I will do here, I will be keeping it inside the variable. Let me keep inside the variable. Let's say this is going to be a document, and here let's say this is my document. Let me run it, and then I'm going to be store this particular document inside where, inside the MongoDB. So simply I can call this collection over here, then insert underscore many, and here I can store this document. Let me copy this one and let me store this particular document. So once I will run it, guys, here my ingestion process will be done. So it is inserting a data. Let's wait, and after inserting, see here I have inserted the data. Now here I will be having 1000 record. Now once you will refresh it, you will be getting your entire data over here, right? You will be getting your entire records and all over here, and one single row, right? One single row. So that is called one document. See here we have a document. So you will find out the data. So title, IMDb rating, awards. Okay, here you'll find out the country, then writer, then here metric, language. This is the single row. This, then other row, then other row. Likewise, we have 1000 row. Okay, so simply we are able to store the data, and corresponding to this data, this full plot, I will be getting the embedding. Right? This is my embedding. Now I can perform the vector search along with the entire data. Getting my point, guys? So how useful it is. Now what I can do, so see, after storing the data inside what? Inside my MongoDB, now I can perform the retrieval operation. So here, from here actually my retrieval operation is going to be start. Okay, because it's a rag, ingestion, retrieval and generation. Okay. So what I'm doing, so here for the retrieval actually, this is the detail which I need to mention. Okay, I will let you know where you need to mention. Just wait. So here guys, what I will do, so let me write the code. So first of all, let me give you the entire function which I written by myself. So here guys, this is the pipeline which is required for creating the retrieval operation, this pipeline. Now inside this pipeline, actually you'll find out, see, we have a different one. So vector search is there, then vector index. Now guys, this is nothing, this is my information of this vector index. Okay, this is the information, number of dimension, embedding, cosine, vector and all. Then here you can see query vector, query embedding. I will let you know what is this. Then here path is embedding, number of candidate 150, means I'm going to be checked with respect to 150 candidate whenever I want to match. And here I'm going to be I'm getting the document, four similar document, four relevant document, right? Now here you will find out the full plot. Okay, so what all column I will be getting along with the embedding. So you will be getting this full plot, title, genres and score. Now see, whenever we are talking about the vector database, there actually we can just play with the embedding, but here if you will check, so along with the embedding we can get the other column as well, metadata also. This is the benefit of the NoSQL database. Okay, but what I have seen in the real time, people are using the dedicated vector database for storing the embedding and NoSQL databases for storing the other data. Okay, now here what I can do, let me tell you. So first of all guys, just a wait. Now here what I will do, so first of all I have to set this one inside the MongoDB. Okay, this particular detail. So just copy it and go over your MongoDB, and here guys, here you'll find out this Atlas search, right? This information. Now here guys, see, I already created this vector index. So let me do one thing. Let me delete it, or here let me show you how to do that, because it takes time. Whenever I'm going to be edit it now, so it takes time. Okay, so here if you want to create so whenever I'm going to be create it now, so it takes time around like 5 to 10 minutes for the activation. So I'm not going to delete it, otherwise and unnecessarily the video will be long. So let me create a new one in front of you. So here what you will do, see, once you will click over there, here you'll find out the different option. Now just click over here, click on this JSON editor and just do the next. Okay, Atlas vector search, Atlas search, Atlas vector search. Just click on this JSON editor and click and do next. Now here guys, remove this one, this part, and write your one over here. That's it. Okay, and then basically what you need to do, so here, see, what is your database? This one. Now select this one and then click on this next. That's it. Getting my point? Yes or no? Yes, let me repeat this part, or else you can rewatch this particular video, that specific part. Okay, JSON. Then here you need to write the vector index. This name should be same with this name. Okay, this name and this name should be same, and then you have to write this information. This is the dimension of the embedding, and this is the path, means embedding a model, embedding column. Here is a cosine similarity, and type is nothing, it's a vector, and you are going to be select this collection. Got it? Now let me do one thing. I already did it, so let me run it and let me show you the retrieval process. Okay, now query embedding. What is the query embedding actually? I will be talking about it. First of all, let me run this pipeline, and here I think okay, this is just for the explanation. Let me show you the entire method. Okay, so this is the entire method which I written for the retrieval specifically. So let me give it to you guys, just a second. Yes, this is the method. So first method with respect to the embedding. So here I will be getting my text, and then I have this vector search. Okay, so this is the entire method guys, this one, vector search. Okay, I'm coming to that. Just wait, let me explain you this entire process, what is happening in actual. And guys, this video is going to be quite long, so please don't worry. It's very important and all, so please watch it till end and you will get lots of information over here, right? So please don't skip it, please watch till end, it's very much important. Now vector search is there. Then what I can do here, here is what, here is my query. So I'll be calling this particular query. Okay, now here is what, here is my final this one, my information which I'm passing to what, which I'm passing to my LLM, right? So this is what, this is my entire retrieval process. Let me check whether I left something or not. Source of information. Okay, get search result. Okay, this is the one. Finally I will be calling it, and yeah, everything I will be explaining you guys, don't worry, everything. Now here is what, here is my combined information. So this is what, this is my final information which I will be providing, to what, to my LLM, right? This combined information I will be providing to my LLM. Now, how I can do it? Just wait over here. See, so this is my method. Here actually user query will be there and the collection name. So whenever user query will come, so this user query will going over here, okay, and then what is going to be do? It's going to be encode the data, okay, text, and it is returning to me a embedding value, right? Here I don't want to be perform the here what I don't want to be do, guys, tell me. Here I don't want to be perform the embedding of the uh the empty text. That's why I've written this particular condition, right? Text dot split. If not, in that case, basically it's going to be a empty one. Now here I will be getting my embedding value, this one. Then what I will do, so if it is none, in that case invalid query or something, then here is what, here is my pipeline, means my query embedding will come. Here is my vector index which I mentioned over there, okay, the complete configuration, it will check over there. Then embedding, it will check inside the embedding column, it will look into the 150 result, because we have 1000 row now, so it will take more time, that's why 150. Then limits 4, it will be giving me a 4 column, a 4 result, 4 relevant result. And here, guys, it is providing me this 4 column, full plot, title, genus, and score, okay, this one. Now guys, see, here is what, here I have to pass this pipeline to this collection.aggregate. Here is what, here is my final result, okay. Now whenever I'm passing the query, so this is my query along with the collection, I'm going to be call this particular method. So here what I will get, guys, tell me. Here I will be getting my result, okay. What I will be getting, tell me. Here I will be getting my result, okay, whenever I'm going to be call it. Now see, so let me show you how I will be getting my result if I'm going to be execute this part and this method. If everything is fine, I will be getting my result over here. See, it is doing a vector search and it will return me a 4 answer, 4 relevant answer. See, this is my query, and here you can see it is giving me this empty one. Now let me check why it is so. Vector index is there. This is my query, okay, it is fine. So here is what, here is my vector index, and let me check whether it is activate or not. Status active. Okay, so fine, guys. Why it is giving me that, I got to know. Let me edit this index. So here, if you will look into this, see why it is giving me, because I haven't selected for the specific collection, that's why. So where I can do that, vector search docs. Okay, not an issue. Let's try to create a new one. So here what I can do, JSON editor. Next, here is what, here's my this one, not this actually. Let me take from here itself, and what I can do, just a second, I can take that particular information. Where is the entire information? This one. Let me copy it and let me paste it over here. That's fine. And then this one, Mongo Rag collection, and then next. Okay, so here I'm going to be create the search index. Let me close it and all set. So not started. Let it start, guys, and let's wait for 1 or 2 minutes. Let's see how much time it will take. I told you 5 or 10 minutes, but let's see how much it will take it. And now if I'm going to see why it was there, why it was not basically working, because the status was sorry, it we haven't selected for that particular collection, okay, because of that there was an issue. Now not started. Let's see, let me refresh it. If it is there, then okay, initial saying okay, active. Now it is active, so let me search it. So finally I am going to be hit the query one more time. So this is the one, and here is the query. Now I'll be getting it. So first of all, okay, this is fine. Here is what, here is a fine, and here is what, here is my collection. Okay, guys, just a second. Vector search, pipeline, aggregate pipeline, and list of result. So where is my collection? Let me check my collection over here, whether it is there or not. So here is my collection. Okay, collection seems fine. Mongo collection, and here we selected for the Mongo collection only. So edit index, okay, embedding and all, everything seems fine here. Okay, Mongo Rag collection. Yeah, it is fine. So let me check. Let me run it one more time. And I think we have a data also. If we're gonna check with the data. So here is my all the collections. Just wait. Mongo Red collection, and inside it I will be able to get the data. Yes guys, my data is also here. So now let's see whether it's working or not one more time. Okay, so here is my document. Okay, this is the one. Let me delete this pipeline. Already I have explained you. This is my collection, and here is my vector search. Okay, not getting why, what is the issue here? Here is a dimension and all, everything is perfect. Now if I'm going to be executed, so source information, or let me check from here guys, just a second, I'm trying to check over here. So here is my query. Okay, in front of you only I'm going to check it. I'm not going to be stop the video and all. Let's see what I'll be getting. Source information, query, combine information. What is the owner? Continue to answer the query. Result? No guys. See, I'm not getting my source information. Means we have some issue over here. So 150 vector search score, vector search, a user query collection, query embedding, pipeline, a vector index, query embedding. It's perfect. Let me check with the name. Okay guys, so let me check with the issue. Now here guys, I am getting a successful result, because see, what was the issue over here? If you will recap the video, so the issue was very minor. There actually I was using this embedding. Okay, EMBEDING means inside the column I written the wrong name. Okay, EMBEDING, not double D. Just like reverse the video and check it over there. You will find out the different column name inside the data. And because of that, it was giving me the issue, because according to the vector index, see here this was the name. I just changed. Now if you will look into the new name, let me show you this data dot head. It was the previous name basically. Now if you will look into the new column name, so you will be find out the embedding. Okay, I just changed. So please try to rename your data. Okay, keep it embedding, because in the vector search you required that column only. Let me show you. See, so here whenever you are passing the path, so it is required EMBEDDING, otherwise it will give you the error. I hope this thing is clear to all of you. That's why I was getting the error. Now let me show you the code again. So here inside the code, if I'm going to be execute this query, so based on this similarity search, I will be getting the response. So here I'm getting the fourth response. So here you can see the first one, then second, then third and fourth, and not even this full plot. Along with that, you can see we are getting the other column as well, like title, genre and score. This is the similarity score. Genre is there, title is there, right? And full plot is there. So we are getting the other metadata as well, and that's the beauty of the Mongo DB, or that's the beauty of the NoSQL database. I hope this thing is getting clear. Now let's try to create our end-to-end pipeline here. So here I'm like searching the query. So whenever I'm passing the query and collection, so here you can see this is the knowledge, and this knowledge I'm going to be append over here. This is my empty string, and inside this empty string basically I'm going to be append this a particular knowledge. Getting my point? So get knowledge, search result. I'm getting the knowledge, means I'm fetching the data from here, from this dictionary. I'm keeping it here inside the result, and then I'm going to be append over here. That's it. So this is going to be become my complete information. So combine information. Let me combine all the information over here. So this is my source information, and here this information, if I'm going to be append along with a prompt. Okay, so this is my prompt, means based on the query, given query I have to answer. So see, now this is my complete prompt. What is the best horror movie? Why? So here you can see this is my complete detail of it. This is my complete detail. Getting my point guys? Yes or no? So now this detail I am passing to my LLM, and finally we are going to generate the answer. So let's see, let's do it. So here I am going to be use the Gemma model from the Google. So let me do it from the, let me use it from the Hugging Face itself. So here I am going to be install this Hugging Face hub. Let me install it, and after that I'll be taking the Hugging Face token. So this is my Hugging Face token guys. I'm keeping my Hugging Face token over here. You can generate the Hugging Face token. Here it's very simple. Need to go through with your profile, then setting. Then inside the setting here, inside this access token, you'll find out the token. Okay, you can create a multiple token as well. So this is my token. I had created second also. So this one, not an issue. Now, here's my Hugging Face token. Now what I have to do, I have to log in. So there are multiple ways I can add on this Hugging Face token during my runtime. This is one of the way. Okay. So here I'm going to be login. Now I can simply pass this token. Okay, this one. So let me pass this token over here. So here is my token, guys. Now let me log in. So once I will click on this login, so here you can see it is giving me a permission. Now I can read the model. So here I'm going to be use this Gemma model, guys, and this Gemma model, it's a model of the Google, it's an open model. Now Gemma 2 billion .it, right? So hyphen IT. So you can find out the complete detail of this particular model over the Hugging Face itself. Once you will search it, you will be getting it. That I will show you in my other video because the video is going to be quite long. That's why let me show you the final output. So here I'm loading the model. Now after that, I'm going to be load the embedding also. Okay, so this is the tokenizer and here is the model, guys, this one. So let me load the model over here, and after that, guys, what I will do, so I will be passing this information, this combined information to my model. Okay, so here this is my tokenizer. I'm passing the complete information to my tokenizer, and here I will be getting the input ID, and finally after that I'll be passing to my model for generating the output. Okay, so let me do it. Let me pass it for generating the response over here. So here is my input ID, and here I'll be getting my response. Now from here, from this response, I'll be getting my final response. Now let me keep the final code, and here it is going to be my output generated by the LLM. Okay, let me explain you again. Let it complete. So what we are doing, see, here is my three method. So it will embed the query, whatever query I'm passing, or whatever query I'm passing through the LLM, right? So whatever query my user is passing, so it's going to be embed all that query, and I will get that query over here, and based on that I am going to perform the similarity search. Okay, this is the complete description of it. Then here is my vector search, means I shown you with one example. Now here I'm passing the same thing over here. See, this is my query. Here I'm passing the query. Here I'm passing my source of information, and then I'm combining all the information, whatever I'm getting. Now this particular information from the database I'm passing to my model. So here is my model, guys. Now let me pass this information to the model. Here I'm tokenizing it. Here basically I'm generating a response, and finally I will be able to augment the response by using the LLM. So here, see, guys, this is my final response. Okay, so query, what is the query? Now here, this is my detail. Okay, and here is here is my answer. I hope this answer you are able to get, and this is the answer basically, which is based on what? Which is based on the, tell me, which is based on the LLM. Now you can ask anything and you will be able to get the answer. So fine, I hope, guys, you got to know about this one. Now in the next class, we are going to be create one combined solution using the Pinecone and the MongoDB. It's a real-time application, and then I'll be coming up with many more solutions. So thank you, guys. Thank you very much for watching this video. Until the next video, thank you. Bye bye. Take care.